I now welcome Dr. Robert Robinson, Chief Scientist at Science Prime, to moderate the audience Q&A panel discussion with this session's three presenters.
So I'll begin by thanking all of our speakers. Those were three excellent talks that really highlighted, the diversity of methodologies that are being applied to studying rain enhancement, but also in revealing some of the underlying physics that goes with rain enhancement. I'm welcome questions from the audience, and I suppose there'll be a way I'll see those questions if they come in. But maybe in the meantime, let me just begin by trying to capture your thoughts on this whole issue of evaluating impacts. And of course, one way, the basic way to evaluate impact is to see whether it rains or not, right? But of course, just seeing whether it rains or not, that doesn't really tell us where in the complex process of rain formation, what's working and what's not working. What are we missing? So maybe I thought I might get your views on what are the key observables that you might look at to see whether cloud seeding is actually working. And maybe I'll start with Professor Hanali.
Okay, thank you very much. Well, based on our research, we obviously want to look at the mixed phase, and as pointed out by the previous presenters, there are lots of ice phase things that we could look at, the ice number concentrations, the size distributions. We'd also be interested in different ways that we could learn about, like what are the processes that lead to this kind of a ice formation. So I think that would be very valuable when we plan how to do the seeding. In our case, of course, any information on the rime fraction, which we have identified as an important variable, would be very valuable. But in general, I would say that any in situ information on the mixed phase cloud would be great for validating and evaluating, for example, our modeling results.
So you've sort of highlighted the in situ measurements in order to.
Well, I'm sort of maybe talking from the point of view of our project. So, what we would need to validate or evaluate the validity of our results, I think that the in situ measurements are very important. But I do agree with the previous speaker that it is very important to combine all these different kinds of data sources. So in situ is important. I think ground remote sensing tools are very important. Satellite information where you can use them is very important, and then combining this all with the numerical modeling tools.
Sure. And so maybe I'll let Dr. Lawson follow up on that, just in terms of what are the observables and what are they in situ or remote?
Thank you, Dr. Robinson. In situ is going to be important because we have to look at the physical chain of events of what's happening. But what everybody wants to know is how much rain are we getting on the ground? That is a tough thing to evaluate because I think, as I mentioned at the end of my talk, it's just impractical to put out a dense enough array of rain gauges to be able to measure this sort of thing. You can try to have a mobile rain gauge radar unit that'll help. But I think what we have to rely on in the UAE are radar measurements, dual pole radar. And there are those measurements in the UAE, so we can use them effectively, and the modeling work. So it's really a three-pronged approach. We have to do the models to see if they will validate the physical chain of events we measure in situ. We have to have radar data to see just what is coming out of the base of the cloud. Because even if we have what we think is a nice process in the cloud, if we don't have more rain at the base, then we're not going to know. And then, as everybody has pointed out, a randomized seeding test eventually will be the provide the statistics that will be needed, along with model support and radar.
Good. So Dr. Tessendorf, just and you showed some great modeling results, and the whole idea of combining observations and modeling. I guess that's what sort of we're all sort of converging on, that aspect. I'm not sure I see how that goes with the statistical analysis. How would you do that statistically, applying that methodology?
So we've done it a few different ways. In the example that I just showed from the Queensland results, we relied on the statistical analysis from the Queensland observations in order to compare with the model results that we had. We've also done that with winter orographic cloud seeding results that we had out of Wyoming. There was a long-term statistical program there that like most, didn't have statistically significant results. And so we ran an ensemble model simulation with WRF WeatherMod to build up a spread of potential results from the model. And the first step in that was to compare with the statistical results and see if the model experiment could replicate those statistical results. The statistical experiments and the data that are collected in them are highly valuable still, even if the statistics themselves don't give you that significance that you were expecting. A lot of times these programs will have the statistical significance. Normally we want to have it greater than the 95th percentile, but sometimes it'll be, say, 80th. Is that meaningful? Well, when we run the model simulations along with it, we can really dive in a little bit more to the processes that are happening in these clouds and try to better understand what's going on and get a little bit more meaning out of that statistical experiment that just due to natural variability of the weather might not have actually had a high enough statistical significance to meet our expectations.
Yeah, I feel like that we've really come a long way in this program in demonstrating that cloud seeding really does work, and now we're just trying to sort of get a better assessment on the conditions where it works better, and how to apply some of that knowledge to the actual cloud seeding operations. Going forward, I see that it would be really advantageous to have a field campaign where we could do a really strong demonstration project that the seeding is effective, and not just effective anywhere. The seeding is effective in the UAE, which presents a unique set of challenges. I wonder if I could get you to think about or say something about how you would assemble, what are the components for a campaign like that? And maybe, Paul, I'll let you begin.
Okay, maybe a little clarity, Bob. A campaign in the UAE, is, for evaluating the seeding. Well, I think it needs the three components we talked about. Well, we need a seeding aircraft and an aircraft to do microphysical measurements. Secondly, we need the radar data. As Sarah showed, when you have the radar data and the in situ measurements, and you can combine them, then you have a much better physical correlation. And then finally, if we can get model results that will actually reproduce, and it's hard to do on an individual case basis, but if we can separate out unseeded and seeded clouds and see if there's a separation there statistically, then I think we have a program that's going to be very convincing.
Hanalei, do you have anything to add to that? I was also wondering about whether there's a place for satellite remote sensing from satellites too.
also remote sensing, I think, from the ground. So I think that the LiDARs that we have operated in the UAE would be very highly valuable for this kind of work, so that you could, this kind of an evaluation projects, that you could get information on the humidity profiles, the aerosol profiles, cloud profiles, and wind profiles. The satellite data, I think that is valuable when it's available. So, I mean, that is sometimes the problem, isn't it? That it might not be overpassing at the time when you need to do your seeding, for example. But I do think that when it's available, it can provide additional information. Perhaps I'm biased because of our project. I do personally feel that in situ measurements and perhaps the crowd-based remote sensing measurements would be the most beneficial.
Let me just chime in, Bob, just for a second. And, you know, with these cumulus congestus clouds that we're targeting, the pixel size from satellites is so coarse that we don't get to see a whole lot. You know, the satellite's going to give us a much better picture of very large storms.
Mm-hmm. Right. And Sarah, the modeling results that I guess these are not assimilative models in the sense that you could take in situ data or remote sensing data and run these models sort of on the fly to assess what current conditions are. Have you thought about that?
Well, yeah, so the WRF model and WRF weather mod can most certainly be set up to run in a data assimilation type setting if you wanted to run it in real time. We do run WRF and WRF weather mod in real time for some of our projects, but have not yet moved to the phase of having data assimilation, mostly because some of the key data that we would want to assimilate is not always readily available. Sounding data and so forth like that would be really highly valuable to improve the model, to nudge the model's vertical profile of the thermodynamic environment, which is so important for cloud formation and getting the model to formulate these clouds and the phase of the clouds properly. But so yeah, that's certainly something that can be done. And if the right program were designed to have, you know, a nice set of additional observations to do that, that would be a great way to run the model. But we do typically run the model in a retrospective manner where we can force the initialization of the model with any number of reanalyses, and that gives us the opportunity then to set up either an ensemble where we run with lots of different initializations, or it just gives us the opportunity to test the model and figure out which configuration compares best with the observations that we have available.
Great. We're almost out of time, but I did want to get maybe your one last comments from you, because what's been so interesting in all these projects is how they've changed along the way. And it's based on this new knowledge that you've gotten and had to make changes. So maybe you could say, just give an example of one thing you know now that you didn't anticipate when you started your project. So Annalie, maybe you could start off there.
Well, thank you. That's a very interesting question, considering that I'm a newbie to the field, so I didn't have any experience on weather modification before I got this project. So I've learned a lot. But I think that the main two things that we have changed compared to the original proposal was that there's been, because we had this international advisory board who sort of guided us towards looking at the sort of the moderately convective clouds in the UAE. We perhaps were thinking of looking at a little bit different types of clouds at the beginning. And then our work package 3 actually changed completely during the project. So we were first thinking of building these emulators based on this cloud scale model. But then our results sort of pointed to a new direction, which we thought that was scientifically more interesting, but also I think that more useful for the operations in the UAE. And then we started developing this artificial intelligence tool, proof of concept tool. And that's, I think, that led to very interesting results.
Great, thank you. Paul, how about you? Have you gotten any new insight?
Yeah, what we learned that wasn't obvious, although maybe it should have been, is just how important the depth of warm cloud is in developing coalescence, developing large drops up higher in the cloud. So, and this reflects simply the temperature at cloud base, because we're talking about the depth between cloud base and the 0-degree level, if we're going to call it warm cloud. And this just wasn't apparent. And as I pointed out, in the UAE, there are very large drops at cloud base, mainly from salt coming in off the seas and salt being kicked up off the deserts. But that is not enough. We have to have a little bit more either depth of cloud base or drops in an intermediate size range in order to produce this coalescence.
Great, thank you. And Sarah, so have you learned anything that's been put into the models that have helped improve the models?
Well, most certainly we are certainly trying to, develop new ways to improve the models with the studies that we've done. But I think the comment that I would say that we've learned, and again, kind of like Paul said, maybe we should have known all along, is just how variable naturally and how variable clouds are naturally. Even in the winter orographic clouds from the snowy campaign, which I showed, very clearly we can detect these unambiguous signatures of ice forming in some of them. They're stable clouds. You think that they're much simpler. But when we look with cloud radar, we see such really fine scale features in these clouds. There's so much, fine scale turbulent features and things that are occurring in these clouds that it's no wonder that it's been so hard over the years to get statistical significance in these types of statistical analyses, and why it's still so hard to get the models to reflect all of those processes. So, the improved observational capabilities to better observe and see these small fine scale features, and then improve sophisticated high resolution models that can simulate them, I think that's really, really key. And with respect to the hygroscopic seeding, one of the other things that I think we've learned and shown in our recent research is that it's really critical to understand that background aerosol condition, because that's one of those conditions that's variable in nature. And if you don't constrain for that in setting up your statistical analyses, it's just going to have that much more natural variability in the study. And this goes for the winter orographic cloud seeding as well. The background aerosol, which has an effect on the ice nucleation, the ice nucleating particle properties, that also has an effect. But especially for hygroscopic seeding, I think it's very important for getting those in situ measurements to understand what your background aerosol is in order to better constrain and even use that perhaps as a variable in setting up a hygroscopic statistical seeding trial going forward.
Great, thank you. And maybe that's some good thoughts to conclude the session on our panel members for their presentations and for answering the questions. And we'll end the session here. And thanks again for everyone.